The moon is not what we thought it was. For more than 53 years, since the last Apollo astronaut left its surface in 1972, humanity convinced itself that the moon was understood. A dead, silent rock, fully mapped, geologically quiet. A gray companion we had already figured out. But on April 6, 2026, that illusion began to break. 4 astronauts aboard the Orion spacecraft, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, became the first humans in over half a century to travel beyond Earth's orbit. As Artemis II swung around the moon's far side, the half permanently hidden from Earth, they encountered something far more unsettling than anyone expected. They launched from Kennedy Space Center on April 1st, riding the most powerful rocket NASA has ever built, the Space Launch System. Standing 322 feet tall and producing 8.8 million pounds of thrust, it pushed them out of Earth orbit in under 5 minutes. After that burn, there was no turning back. Their trajectory, known as a free return path, meant that even if every engine failed, the moon's gravity would carry them around and send them back toward Earth. It's the safest route, which says everything about how dangerous this mission truly is. As Orion slipped behind the moon at just over 4,600 miles above its surface, the crew entered the most isolated moment any human has ever experienced. For 40 minutes, the moon itself blocked all communication. No contact with Houston, no telemetry, no backup, just silence, and the most ancient, violent landscape in the solar system unfolding beneath them. Victor Glover tried to describe what he was seeing before the signal cut. He struggled. His words, transmitted just before blackout, were simple but striking. Humans may not have evolved to process what they were looking at, and then the connection was gone. So what did they see? To understand that, you have to understand how different the far side of the moon really is. The side we see from Earth is relatively smooth, covered in vast dark plains formed by ancient lava flows. Nearly a third of it is made of these basaltic seas, giving the moon its familiar face. The far side is the opposite. Instead of smooth plains, it is a chaotic wall of craters layered on top of older craters, stretching across a landscape that looks like it has been hammered relentlessly for billions of years. Its crust is roughly 50 kilometers thicker than the near side, and no one fully agrees why. One leading theory points to a colossal impact near the lunar South Pole, an event so violent it reshaped the moon from the inside out. That impact created the largest known crater in the solar system, the South Pole Aitken Basin, a structure over 2,500 kilometers wide and up to 13 kilometers deep. If placed on Earth, it would stretch across much of the United States, but what lies beneath it is even more disturbing. Data from NASA's Grail mission revealed a massive anomaly deep below the basin. A dense object buried hundreds of kilometers underground, weighing at least 2.18 quintillion kilograms. Scientists believe it may be the metallic core of the asteroid that caused the impact, still lodged inside the moon after more than 4 billion years. Like a fragment the moon never managed to expel. For the first time in history, human eyes saw the edge of this structure directly, not through data, not through images, but through a spacecraft window. And that was only the beginning, because what truly unsettled the Artemis II crew wasn't just what they saw, it was how different everything felt, not just visually, but physically, almost psychologically. The farther Orion moved across the far side, the more the moon stopped looking like something familiar and started feeling like something alien. There were no wide, calm plains, no recognizable face, no patterns the human brain could easily process. Just layers of impact scars stretching in every direction, some so old they had been shattered, erased, and rewritten by newer collisions. A history of violence recorded in rock, going back nearly to the birth of the solar system. Christina Koch later described it as looking down at time itself, broken into pieces. And then there was the light. On the moon's far side, light behaves differently. Without atmosphere, there's no scattering, no soft glow, no gradual transitions. Shadows are absolute. Light is brutal. When sunlight hits the rim of a crater at a low angle, it creates contrast so extreme that depth perception starts to fail. Craters don't look like depressions anymore. They look like holes, black voids cut into the surface. Victor Glover focused on what astronauts call the terminator, the shifting boundary between day and night. Along that line, the moon transforms. Peaks catch sunlight like islands floating in darkness. Valleys disappear completely. Entire regions look like they've been erased. At one point, Glover said it felt like looking at a map of black holes you could fall into. That's not a scientific description. That's a human reaction. And it matters because this is something robotic missions don't capture well. Cameras flatten shadows, sensors average data, but the human brain reacts instantly to contrast, depth, and motion, and sometimes it reacts with discomfort. The Artemis II crew wasn't just observing geology, they were experiencing something their minds weren't fully prepared for, and that psychological edge only sharpened as they moved deeper across the far side. Because beneath that surface, nothing is simple. The South Pole Aitken Basin isn't just large, it's fundamentally abnormal. Its size alone suggests an impact so powerful it didn't just crater the moon, it altered its internal structure. Heat from that collision may have redistributed material across the entire lunar body, pushing radioactive elements toward the near side and leaving the far side colder, thicker, and more rigid. That could explain why volcanic activity, the kind that created the dark Maria we see from Earth, barely exists on the far side. But it doesn't explain everything. The buried mass anomaly still doesn't fully match predictions. Its density, its shape, even its gravitational effect don't fit cleanly into existing models. Scientists call it the most likely explanation. But most likely doesn't mean understood. And that uncertainty is what defines the far side. It keeps refusing to behave the way it's supposed to. The crew saw more evidence of that as they continued their flyby. Subtle color variations appeared across the surface. Faint blues, muted greens, tones that don't show up clearly in processed orbital images. To the naked eye, these shifts matter. They reveal differences in mineral composition, differences in age, differences in how the surface has been exposed to space over billions of years. Jeremy Hansen noted that some regions looked younger than expected, almost as if they had been resurfaced or altered more recently than surrounding terrain. Not recently in human terms, but recently in geological time. And then there was the heat. In 2023, researchers detected a thermal anomaly beneath the far side, a region about 50 kilometers wide that was noticeably warmer than everything around it. That alone would have been unusual, but the composition suggested something even stranger: granite. On Earth, granite forms through processes that require water and plate tectonics. The moon has neither. It shouldn't exist there. And yet, something resembling a massive granite body is buried beneath the surface, still retaining heat after billions of years. A leftover system, a remnant of processes we don't fully understand. The Artemis II crew didn't see the anomaly directly. It's too deep, but knowing it was there changed how they interpreted everything above it. Because suddenly, the moon wasn't just ancient. It was complicated, possibly still active in ways we don't expect. And then came the structures we haven't even explored yet. Lava tubes, massive underground tunnels formed when ancient lava flows cooled and hardened on the outside while molten rock continued to move beneath. When that flow stopped, it left behind empty corridors, some potentially kilometers wide. From orbit, scientists have identified entrance pits that may lead into these systems, dark openings scattered across the lunar surface. No one knows how deep they go. No one knows what conditions exist inside them. Temperature, pressure, trapped gases, untouched geological layers, all of it is unknown. From above, they look like shadows. From the right angle, they look like entrances. And as Orion passed overhead, the crew knew they were looking at places no human had ever seen up close. Places that may one day become shelters for future missions. Or reveal something completely unexpected. But the most surreal moment of the mission didn't come from the surface. It came from the sky. As Orion moved into position, the sun began to slip behind the moon. From Earth, a total solar eclipse lasts a few minutes at most. From lunar orbit, it lasted nearly an hour, 54 minutes of totality. The sun disappeared, replaced by a blazing halo, the corona stretching outward in delicate, violent strands of light. The entire edge of the moon lit up, every ridge and peak outlined against that glowing ring. Jeremy Hansen described it as if the moon was burning from the outside. And in that moment, the crew saw something else. Flashes, brief, sudden bursts of light on the surface below. Small, instant, gone. At least one was confirmed by multiple crew members. Most likely, they were micrometeorite impacts, tiny fragments of space rock slamming into the unprotected lunar surface at extreme velocities. But here's the part that matters. There is nothing on the moon to stop them. No atmosphere to burn them up. No magnetic field to deflect them. Every particle, every fragment, every high-energy projectile hits the surface directly, and occasionally, visibly. For centuries, observers on Earth have reported unexplained flashes on the moon, events that appear and vanish too quickly to study. Some are now believed to be impacts, others remain unexplained. The Artemis II crew may have witnessed one of these events in real time, or something else, and they had no way to confirm it, because during the most critical part of the mission, they were alone, completely cut off. No communication, no assistance, no immediate rescue if something went wrong. If a solar storm had erupted during that blackout window, they would have had minutes to react, if they even knew it was happening. And that brings us to the most dangerous part of the entire mission: radiation. Beyond Earth's magnetic field, space is not just empty, it is actively hostile. Galactic cosmic rays, particles accelerated by supernova explosions, move at nearly the speed of light. They pass through spacecraft walls, through human tissue, through DNA. Solar particle events can flood space with radiation intense enough to become life-threatening in hours. Artemis II launched during solar maximum, the peak of the sun's activity cycle, which means the risk was not theoretical, it was elevated. The Orion capsule provides shielding, more than Apollo ever had, but not enough to fully protect against everything. And that's why this mission matters beyond exploration. It's not just about where we can go, it's about whether we can survive staying there. Scientists are already studying biological countermeasures, drugs, genetic adaptations, cellular resistance. Because engineering alone may not solve the problem. Human bodies were not designed for deep space, and Artemis II is testing that reality in ways no mission has done in decades. The crew carried biological samples, their own cells, to study how deep space radiation affects them over time. Because the real data isn't just what they saw, it's what happened to them while they were seeing it. And through all of this, one moment stood out above the rest: Earthset. As Orion cleared the far side, the crew watched Earth disappear behind the lunar horizon, a small blue crescent, slowly sinking out of view. We've all seen Earthrise, the iconic image from Apollo 8, where Earth appears above the moon's surface. This was the opposite: Earth, leaving, not rising, not appearing, vanishing. And in that moment, the scale of everything changes. Every city, every ocean, every person, every memory, gone from view, hidden behind rock, separated by distance that no human being can cross without machines, fuel, and precision. Christina Koch described it simply: when you see Earth from that perspective, you realize how much everything depends on it. Not just life, everything. And that realization doesn't feel poetic when you're out there. It feels fragile. Because for those 40 minutes, Earth wasn't just far away, it was unreachable. And when the signal finally came back, when Orion re-emerged and communication returned, mission control erupted. Not because something went wrong, but because nothing did. The mission continued. The data kept coming. Thousands of images, observations, measurements, most of them still not fully analyzed. Because what Artemis II brought back isn't just footage, it's questions, new ones, harder ones. Why is the far side so different? What exactly is buried beneath the South Pole Aitken Basin? Why does granite exist where it shouldn't? What's inside the lava tubes? What caused the thermal anomaly? What are those flashes? And perhaps most importantly, what else are we missing? Because the more we learn about the moon, the less it looks like something simple. The far side isn't just another hemisphere, it's a record of impacts, of heat, of internal forces, of events that reshaped an entire world, and we've barely started reading it. For decades, we treated the moon as a solved problem, a completed chapter. Artemis II just proved that it isn't. It's the beginning of a new one, and the deeper we go, the more uncomfortable that truth becomes, because the moon is not what we thought it was, and whatever it really is, we're only just starting to find out.